Hey, Algebra 1, good morning. We are starting Chapter 3. Chapter 3, Section 1, we're looking at graphing relationships. How do you match simple graphs with situations? Well, let's take a look at this graph here where we have air temperature was constant for several hours at the beginning of a day, then rose steadily for hours, and it stayed the same temperature for most of the day, then dropping sharply at sundown. Choose the graph that best represents this situation. So we're looking at the time on the y-axis is how it goes up and down, and the time on the x-axis is how it goes across. So constant for several hours at the beginning. So these two have a constant at the beginning, but the third one does not. Then rose steadily for several hours. That's both of those. That's rising steadily. And then stayed the same temperature for most of the day. Well, that would have to then be graph B. And then suddenly dropped at sundown. Obviously, we're looking at graph B. Let's talk about discrete graphs. Discrete graphs are distinct points. For example, Simon is selling candles to raise money for his school dance. And for each candle he sells, the school gets $2.50. And he sells 10 candles. Or he has 10 candles to sell. If I make this as a graph of candles he can sell and money he can earn, then if he sells one candle, he can earn $2.50, and 2 would be $5, and so forth. Notice, though, that there's never a line that goes across this because you can't sell part of a candle. You can't sell half a candle. A continuous graph is a graph that connects the lines because everything in between could be a part of the solution. For example, Angelique's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same, and as she increases her pace, her heart rate rises at a steady rate as well. When she begins to run, her heart rate increases more rapidly and then remains high while she runs, right? So while she's walking, it's a nice steady rate. Notice it doesn't go all the way down because that means she would have no heart rate at all and she would be dead, right? That's not good. So it increases as her heart, as she picks up the pace and begins to run, it goes higher even still. And it's going to remain that pace while she's running, and then it'll gently decrease as she slows down. Then it never goes flatline, because if it went flatline, she wouldn't be with us anymore, right? Now you try. Here's a couple of situations, and sketch graphs that show whether they're continuous or discrete. If you're watching this at home, pause the video and then turn it back on when you're ready. Okay, let's take a look at these. And the first example is discrete because he's taking or she's taking an 8-week keyboarding class, and at the end of each week takes the test, right? So there's just one test per week, so they can only go up by that each test. For the second one, he is draining a water tank and opens a valve, then opens another valve, and closes the first valve. So it starts to lower the water level at a continuous rate, then it goes faster because there's 2 valves open, then closes the other, so it is a slower pace again until it's all gone. Let's talk about ordered pairs. Ordered pairs are X and Y. They're in alphabetical order. Our graph has an X coordinates. They're positive or negative. And the y coordinate, up and down, is also positive, negative, up for positive, down for negative, right for the x value if it's positive, and left if it's negative. The point of origin is right in the center at 0, 0. And then we have quadrant 1. We have quadrant 1, which is positives and positives. Quadrant 2, which is negative and positive. Quadrant 3, which is negative, negative. And quadrant 4, which is negative, positive. And they all go this way, in that direction. But we'll explain more about that later. So we're plotting points. If I have the point 2, negative 4, my x value is 2, and my y value is 4. So I start at the point of origin, and I go right 4, and then down, right 2, and then down 4. And that is my point. If I plot this one, I go left 5 and up 3. Again, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Go ahead and try these, plot these points, pause the video, and then check your solutions. Let's see how you did. This is where you should have plotted these points. So for homework, you're going to have 3-1 on the textbook, numbers 3 through 5, 10 through 12, 23 through 24, and then I will be giving you a puzzle as well to work on and introducing you to your group project. Have a great day.